In this video, we're going to go over using Revit and elumtools to lay out, design, and calculate your interior electrical lighting. In doing that, we're going to use this simple sample model that prior to, I think, 2015 was the basic sample model for any models in Revit. What we have done, just to get it going, is I have installed some light fixtures. Cut it in with the section box. We've installed several different types of light fixtures on the ceiling in here, and we'll get a better look at that in a second. We'll go to the ceiling plan for level 2. So just very simply, it is these 5 these are up downs, surface mounted on the ceiling here. These are 4 pendant lights located above the living room there, and these are 6 downlights over the loft area. So just to show the floor plan, that the ground floor is the living room, is this space, and the second floor plan, you have a corridor, a loft, and the living room below. So you have a double height space up in the front here. So what you're going to find is when you're using elumtools to lay out your electrical lighting, you're going to spend a lot of time in Revit and very little time in elumtools, because most of your setup will be getting the families ready, placed, and properly configured within Revit. So let's go over how to configure some of these light fixtures. What you're going to find is, with all of these light fixtures, as I flip through my views, let's look at this pendant. You're going to typically go online and find a fixture that is very similar to what you want to use, and then you can configure it to what you want it to be. But all of these fixtures have cut sheets with them. So these cut sheets will tell you about that light fixture, most specifically how it is lamped, and all of the different configurations of its lamping and size. So when it comes to analyzing the light, the finish of the fixture doesn't matter as much as the mounting types, the size, and the lamps, and the lamp type especially. The reason why I'm focusing on this is because what you have to do for all of these fixtures that you place inside Revit is you have to find an IES file with the proper configurations. And now these normally come directly with the file from the manufacturer. So you can go to the manufacturer's website and download these IES files. In this case, I've downloaded them for these pendant lights. So you'll see there's 2 different types. And there actually is only one type of lamping that they allow for, and that is the T5, which is their most common lamping. So I've actually already configured these lamps, but I'll show you how they were configured, and then we'll configure these downlights. So with these, what you want to do whenever you're configuring one of these lights is go to Edit Type, and in the Type Properties, down in the last section, you will find a photometric web file for its photometrics. And here is where you can select that file that you want to use. You'll see that Revit has defaults in here, which is actually fairly helpful. They have a lot of different IES files for something as simple as a 2x2 2-lamp fixture to more complex fixtures. But you're always best going right off of what you download from the manufacturer, which is what I already have programmed into this one. So we don't actually have to do much with this one in configuration, so I'll hit OK. One way to check to make sure all of your lights in your space are configured properly is, once we're in elumtools, we go to that tab, you have a Luminaire Manager. And so if we click this, it'll tell you everything that's active in the file and what its IES file is. So you'll see that my surface mounted fixtures and my pendants have IES files on them. So there, they should work perfectly fine for the analysis. But then the incandescent does not. So first thing we need to do is find a incandescent IES file. Now, when I made this model, I just installed the generic Revit Downlight family. You can find that by as simply as going Insert, Load Family, and go to Lighting Fixtures. For architectural, these are internal lights, and I just did the recessed can downlight. These are all good starts, and all of these can be configured to more accurate light sources later. You'll actually find once you have the right IES file, it doesn't matter what your fixture looks like, because the IES file is what's actually casting the light, and the fixture shape has no impact on that. So since it's already loaded in, what we're going to do is click on it, tell you what it is. You go to Edit Type, and you'll find that it does not have that IES file input, which, don't think that all is lost. It has a lot of settings for rendering and whatnot, but what we want to do is we want to get the exact downlight, correct downlight, and the way it casts its light. So what we have to do is just simply edit the family. So while it's still selected, click Edit Family. It shows you a very simple version of that light fixture. Click on the light source. It's normally in yellow, and so you click on the light source. This is all you have to change in the family. Go to Light Source Definition, and you're going to tell it that I don't want it just to be a simple cone down. I want it to be a photometric web, and hit OK. And now you've changed the family so that it's looking for a IES file. So you load this into the project, overwrite the existing version, and now when we click on it, if I go down to the photometrics, you'll see now it's changed. Now it is looking for a photometric file, and it has a generic one set. We don't want generic, so we want to hit load. And I've actually already downloaded a simple downlight IES file. There's several different ones. So the one I want is the one on top. I just went to Cooper Lighting, found an LED downlight that matched the specs that I was looking for, and downloaded some different IES files for it. Hit OK. And hit OK. And since all these downlights are the same family and the same type, they all receive that new IES file. And so once I've done that, go back to elumtools, check my manager. Everything looks like it has an IES file, which is a good first step. The next thing you want to do is just check and make sure the light sources look correct. So to do that, I just click on the fixture I want to look at, and I go to light source. My screen is a little squished here. So my screen is very, my preview box here is very small. But what you want to do is go to light source and look at the preview box and see how the light looks like it's coming out of the fixture. With this newer version of elumtools, it tends to get the light source correct. The previous years, a lot of times the light source was actually coming out at an angle and not correct. So you can flip through each of your fixtures, and this is again completely miniature, so that you can't see it in this view. But flip through all of them, make sure the light source looks like how you expect it to be coming out of the light fixture. And once you're done with that, hit OK. And now we're ready to do our analysis. So if you've watched the daylighting video, or if you've done daylighting in elumtools, this is very similar. So we're going to keep it on general use, because general use is electrical lighting only, and we're going to do some analysis. So I'm going to go to level 1, and I'm going to say I want to add some points, a room work plane, select the room I want to do it on. I'm going to tell it I want to make sure it's 2.5 feet above the floor, and it's a 2x2 grid. We're looking for a luminance. And that's the main thing I'm looking for down on the floor. You can obviously add more points and more room work planes, or you can even do planar faces with this button. But we're going to do that, and we're going to do multiple rooms, because I want to get the living room and I want to get the loft and the corridor on the second floor. So one thing that is to keep in mind is you're not going to be able to flip views very easily using the project browser once you start doing your calculation selections. So have the two levels you want to use open, and then use Control Tab or Control Shift Tab to flip between the two. So that way when I tell it to go, I want to do multiple rooms, I'm going to select the living room, I'm going to hit Tab once, and I'm going to select the loft and the corridor. And then I'm going to hit Finish. I'm going to combine these since they are touching rooms, and I want the light to share between the rooms. And now elumtools is going to open up its analysis window, and it's going to start doing all the calculations. And what I'm going to do is I'm going to pause this until it's done with the calculations, so you don't have to sit through and watch all of this. So the calculation is now complete, so I can look and see what our results are. Turn this around. The way one of these fixtures is built, it does create a fairly odd, a little zoomed in, fairly odd display, because there's the way the IES file is made, there's a light source that becomes visible once you actually render it. So while the light fixtures don't look like this with this glowing box in them, that's just how the IES file works. So the first thing you see is an accurate rendering of where the light's going to go. So then you can change it to be an image of a luminance and switch it to be foot candles, and then go to your false color mapping or your pseudo color, and you can start to see what's happening in the space. And you can see your foot candle levels at a 2-foot interval down here. You can look for hot spots on the walls. You can look for hot spots on the ceilings. Typically when designing, you want to prevent burning out spots on the walls, as it draws a lot of attention to it, unless it actually is something you want to draw attention to. You'll also see that with this rendering, it's not showing you the curtain wall here. And I can show you why that is happening. Because as we rotate around, see how it never comes back? The reason why that is the room, there's a lower wall below the curtain wall here. The room stops at the wall below, which is before it touches the curtain wall. So technically the calculation is not reaching that face. I think the same thing is happening right in here. And there's a way around that. I could show you what it is, but I just wanted to move through the space a little bit more. You can kind of go in and see how everything was working. So you do have a very bright location on the walls in here with these pendant lights. And these pendants are projecting light up and down. And same thing with these surface mounted fixtures. They go up and down, so they create hot spots right around them. Let me get rid of the pseudo color. You can actually see the hot spots on the walls and on the ceiling. Alright, so just to go over why that wall is not calculating, we're going to close this view. And I'm going to cut a section through just to show you what's happening. So in this section, what I'm going to do is I'm going to go to Visibility Graphics on the View tab, And I'm going to tell it that I want to see the rooms. I want to see the interior fill of the rooms. Here you'll see, because of this wall up on the top, that it's a bounding wall. As soon as the room, which is a 3D volume, strikes that wall, it stops before it meets the mullions. Another thing you might find is if some of your spaces are not being calculated, like on the ceiling up high in these double height spaces, sometimes by default in Revit, if you go to the Architecture tab and Room and Area, you'll find under Area and Volume Computations that you're set to areas only. When you're doing this kind of analysis, you really want areas and volumes. And so what that allows you to do is, once you have areas and volumes selected, you can come in and cut these sections and make sure that your room isn't doing something like this. You don't want to see your room ever stopping short of the ceiling or a roof. And once you have your volume turned on, you can actually click on it and control the upper height. So if I pull this through, we're still going to ignore that. It'll go up to all of the bounding elements, and that is the ceiling. If I click on the ceiling, you'll see it's room bounding. The walls, these are all room bounding, and the roof. So, a couple ways. For one, I think I could set this wall to not be room bounding and switch it to the curtain wall. But a lot of times you do want both the walls to be room bounding, but you don't want your room to stop there, because then the calculation won't include the curtain wall. The way to get around that is to not do your calculation by room. What you want to do, and this does make it take a lot longer to calculate. And if you want to do a work plane calculation or a calculation along a wall, you will need to, instead of doing it by room work plane, you'll need a planar face, and you need to place that family somewhere where you want to do the calculation. So click on it, say 2x2 grid, that's good, and I'll place it on the floor. So now we'll still get results on that floor, but the difference is now I'm going to select my whole model first, go to elumtools, calculate, and calculate by selected elements. So this will make it take much longer, but it will also include all the elements that are outside of the room that the room volume is not touching. So depending on the kind of work you're doing, you might need to do this in order to get your analysis on all of the walls of your space. Now I'm going to pause this again until it finishes and we can review what comes up. Okay, calculations should be pretty complete now. You'll find when you calculate by, we're upside down, you'll see when you calculate by everything selected, it really does grab everything and it makes it harder to see into the space. But once we get in there, we should be able to move around a little bit. And then we can do the same thing, switch to illuminance, switch the foot candles, and you can do your pseudo color. And you can see just how the light reflects off of the glass and the mullions, and that it does make a difference in how it's reflecting around the space. Pretty sure I'm in a wall right now. That's it. That's how to do electrical lightings with Revit and elumtools.